Hi friends, welcome back to my channel. Thank you for always choosing Online Maths Expo. What we're going to do today is very interesting. I don't know why students usually find it difficult to solve problems on quadratic inequality. Does it mean that it's really hard? No. Join me in today's class. Please make sure you stay through the end and have your pen and paper because it's going to be interactive. Okay? Join me now so that I will tell you all the secrets you need to know about quadratic inequality. Okay, let's take it to the board. You know you cannot do well in quadratic inequality if you are not good at quadratic equation. I've already treated a topic or some questions on quadratic equation. I will leave the link down the comment section. But I was just refreshing our memory with one of the questions. Then we can now switch to quadratic inequality. Okay, we are asked to solve this. You know, when we talk about equation, this is what makes it an equation, the equality sign. Now, we are asked to solve this. How do we solve it? What you simply do is, you get two numbers that when you multiply it, it gives you minus 18. When you add it, it gives you minus 3. So what are the two numbers? You have 6 and 3. You can have minus 6 and plus 3. Minus 6 plus 3 will give us minus 18. Will give us minus 3. And minus 6 times 3 will give us minus 18. So the two numbers we are choosing are minus 6 and plus 3. Now what do? It will now be, because it's x squared, you open two brackets, and you're going to have x. Remember, the two numbers we chose are minus 6 and plus 3. So you have x here and have one x here, then minus 6 plus 3. Everything should be equal to 0. So in that case, it means that x is equal to, when this minus 6 crosses to the right-hand side of the equation, it becomes plus 6. And when this plus 3 crosses, it becomes minus 3. So the value of x here are 6 and 3 only. And that is why we say that in quadratic equation, we only talk about exactness. So the values of x can only be 6 and 3 minus 3. Nothing more, nothing less. Okay, if you have understood what we meant by that, follow me through to quadratic inequality. We are going to repeat this question. Remember, when we talk about inequality, there are signs that make it inequality. And what are those signs? We have greater than, we have less than, we have greater than or equal to, we also have less than or equal to. Please, if today is your first time of coming across us, remember we have treated this introduction to inequality. I'll also leave the link in the comment section so that you go through it and see how we introduce the inequality to our students. Okay, now for these are what makes it inequality. Now let's do this. What we're going to do is, I'm going to use this question on all these inequality signs we have mentioned, which are greater, this one is greater than, this is less than, this is greater than or equal to, and this is less than or equal to. So we are going to use this one question on all these four signs you have listed on the board. Please make sure you are still with me and with your pen and paper because it's going to be very interactive. Okay, let's take it there. The first one we want to concentrate on is greater than. Please make sure you are paying attention because when we introduce greater, the same approach you use for greater is what you use for less than. It's also what you use for greater than or equal to, and that of less than or equal to. We are testing with that of greater. Now we have x squared minus 3x minus 18 is greater than 0. Two things. One, solve this inequality as an equation. Second, test for the values of x, the range of x that will satisfy this particular inequality. Just two things. Okay, let's take the first one. The first one is solving it as an equation, and by doing so, we're going to have x squared minus 3x minus 18. Look at what we've already solved as an equation, so it will be equal to 0. So in that case, like what you did, you have x minus 6 and x plus 3. Please, if what we did is still confusing, kindly pause the video and go back to how we solve this quadratic equation, then follow through. Everything should be equal to 0. So we have that x is 6 and minus 3. Now the equation part of it ends here. Now let's introduce the inequality. In introducing the inequality, you will use your number line. You know, you cannot do well on inequality without knowing how to use your number line. So let's draw a number line as usual. Remember, this is the origin, and from the origin to the left-hand side gives us negative values. From the origin to the right-hand side takes the positive values. So we now have 6 and minus 3. Please be careful. Most students usually mistake this. Sometimes they will write the negative at the right-hand side, and at the end of the day we'll have a wrong answer. So be careful with the signs. So here is where you have negative 3, and here is where you have positive 6. Now supposing we pick any value from here down to this place, to the negative axis, and you substitute it in this inequality, everything is greater than 0. Then you know that the values of x here are the ones that will satisfy that inequality. Let me take that again. In testing for the range of values of x that will satisfy this inequality, remember in inequality we talk about range, we don't talk about exactness. And you know, in talking about range on the number line comprises of, you have, like here we have minus 3, you can have minus 3.1, minus 3.2, minus 3.3 and others. You have both the natural, whole number, rational and irrational numbers are all contained on this number line. So that is why we say that in inequality we talk about range of numbers, which also includes the negative, the whole number part and the decimal part of such numbers. But in equation, we only concentrate on the exact values. So this is minus 3, and if we pick minus 3, here is minus 4, here is minus 5, down to negative infinity. Between minus 3 and 6, here is minus 2, minus 1, this is 0, 1, 2, 3, down to 6, and here is 7, 8, down to positive infinity. Now, we are concentrating on these points. Pick any value from here in the negative side and test it here. If everything is greater than 0, then it satisfies the inequality. Then, if you do so, it means that the values of x at this outside point also will satisfy it. What are we trying to say? We are concentrating on 2 points. Is either that the values of x within this region satisfy the inequality, or that the values of x at the outside, look at where we call the outside, this part and this part. Any values of x you pick either from here or here and substitute and it satisfies the inequality, then you know that that is the solution to the question. So I always encourage my students to pick a number that reduces the work for them. So supposing we pick a number from the inside and we pick 0. If we substitute 0 in this inequality and at the end of the day our answer is greater, we are concentrating on the sign greater, our answer is greater than 0, then we know that this region satisfies the inequality. So let's test for that. Substitute 0 in this inequality, we have 0 squared minus 3 into 0 minus 18. 0 squared is 0 minus 0 minus 18. So we have minus 18. Is minus 18 greater than 0? No. Minus 18 is not greater than 0. And in that case, it means that none of the values here will satisfy the inequality. So which value will not satisfy the inequality? If we pick any value from this point down to negative infinities, or pick any one from here, let's pick one and test. Let's assume we pick minus 5. So we have minus 5 squared minus 3 into, remember we are substituting it here, into minus 5 minus 18. Minus 5 squared will give us 25. Minus 3 times minus 5 will give us plus 15 minus 8. You see that 25 plus 15 will give us 40. And 40 minus 18 will give us 22. And you see that 22 is greater than 0. So what it means is that any value of x I pick in this region or in this region, I will encourage you to test for any value within this region, and you will also see that whatever thing you will get will be greater than 0. So in our conclusion, we will say that our solution is x is less than, remember the question is on greater, so it will now be x is less than minus 3 and x is greater than 6. That is the solution. Now supposing we want to represent this on a graph, most times students are asked to solve and show our answer graphically. Now how do we show this graphically? Let me pause a little. Please, if today is your first time of joining us, please subscribe to our channel to encourage subsequent videos, and make sure you click on the notification button so that you always be the first to get our latest updates on any of the teachings. Please subscribe. Okay, now let's look at how to represent this on a graph. If you want to represent this on a graph, let's do it at this part. Please manage my board. We are going to have, remember this is minus 3 and this is 6. So if I'm representing it, remember this kind of graph is a quadratic graph and it's also a minimum graph. How do I know it's minimum? It's minimum because the coefficient of x squared here is positive. So if the coefficient of x squared is positive, it means that such graph is going to be a minimum graph. So minimum graphs usually take this shape. So this is how to represent it on a graph. Supposing the question says show it graphically. And since we have represented, which region should we shed? The shaded region is the region that will satisfy the inequality. But remember that you've already seen that the values of x within this point to this side of the region are the ones that satisfies, and values of x from here to this point are also the ones that satisfy. So in that case, the region we are going to shed are this part of the region and this part of the region, because any value you pick from here, if you pick 7, you will not pick 6 because you only have greater. If you pick 7, 8, 9 and so on, you can pick minus 4, you can pick minus 5 down to negative infinity. Any value you substitute here will be greater than 0. Okay, now that you understood this, the other ones we are going to discuss will be, we are going to refer back to what we have done here. So let's do that together. Let's take it to the next part of the boards. Please manage our board with us. Okay. Now we have done the first one on greater than or equal to. Let's take it that the question is x squared minus 3x minus 18 is greater than or equal to 0. Here we are discussing greater than or equal to 0. The same approach like we have said it from the beginning. So in that case, if we are going to have x minus 6 and x plus 3 is equal to 0, x is 6 and x is minus 3. So if I draw my number line, I will have here is minus 3 and here is 6. Now we test. The same testing we did there, remember we chose value from the inside as x equal to 0 and tested. We have 0 squared minus 3 into 0 minus 18, which gave us minus 18. Now my question is minus 18, is it greater than or equal to 0? No. And if you say no, it means no value within the region will satisfy the inequality. So which one is satisfying it? This part, as we have shown here. But look at the difference between these two. The difference between these two now is, if I want to get the solution of this inequality, what will be the same shading, but there's a little difference. The little difference there is that this question has greater than or equal to. So if it has equal to here, it means that the solution will now be equal to x is less than or equal to minus 3. See the difference? This one is only less than because the question is not having a equality sign. I hope you are following. Whereas this one has equality sign. So your answer will also have less than or equal to minus 3. Then you also have x is greater than or equal to 6. So what it means is that the same approach you use for greater is what you use for greater than or equal to. The only difference there is on how you present your solution. I hope what you did was clear. Please, if you are still confused, kindly pause the video, go back to what we have discussed, and then follow through. Then let's do the last one. Okay, the last one is, supposing we have this, that's the third one. We are looking at less than now. And if we are looking at less than, we change this to less than 0. The same approach like I have said, and that will give us x minus 6 and x plus 3 is equal to 0. X is equal to 6 and minus 3. Do the same testing. Here is minus 3 and here is 6. So what do you have? You test the same testing. Pick any value. Pick 0 to reduce it faster for us. So we have 0 squared minus 3 into 0 minus 18. At the end, we have minus 18. Now, my question is minus 18 less than 0? Yes. And if minus 18 is less than 0, it means that any value I pick within the region will satisfy the inequality. So in that case, within the region, what do we have as the solution of the inequality? For the inside the region, it will be, it is from here down to this point. So if you want to represent it, it means that the arrow will move this way and this way. So representing it, it will give us, this is x is greater than minus 3, and this one is x is less than 6. So if you gather them together, it will give us minus 3. Remember, if you change the position, the inequality sign changes. So for x is greater than minus 3, to be minus 3 is less than x, and x is also less than 6. So this becomes the what? The solution for this. Now, supposing you want to represent it on a number line, which one, how do you represent? It's still a minimum curve. So we're going to have this curve. And if we have this curve, which region do we shed? The region we are going to shed is the inside region, because that is the region that satisfies the what? Inequality. Meaning that if I pick any value within here and substitute in this inequality, it will still give us the answer must be less than what? 0. I will encourage you to try less than or equal to. Try this. Try less than or equal to and give me your answer in the comment section. Please remember to share. If you find this video very interesting and helpful, please share to as many that will need it to help us solve this problem of mathematics phobia. Thank you very much. Till meet another time. Bye-bye.